Hello everyone, I am Yogita studying in Sri Venkateshwara College of Engineering. Today I am going to talk about Huffman trees, which comes under the subject Design and Analysis of Algorithms. The contents to be covered in this video are: what are Huffman trees, steps to solve Huffman tree, encoding, decoding, an example, and applications. Now let us see what is an Huffman tree. Huffman trees are a data structure used in computer science to efficiently encode and decode data. They were invented by David A. Huffman in 1952 while he was a graduate student at MIT. The basic idea behind Huffman trees is to assign shorter codes to more frequently occurring characters and longer codes to less frequently occurring characters. This allows for efficient compression of data, which is especially important in fields like telecommunication and data storage where space is at a premium. Huffman trees have many applications in computer science beyond just data compression. For example, they can be used in cryptography to encrypt and decrypt messages, in image and video processing to compress and decompress media files, and in network routing to optimize the flow of data between nodes. Their versatility and efficiency make them a valuable tool for any computer scientist to have in their toolkit. Steps in solving Huffman algorithm. Step 1. Initialize n one-node trees and label them with the characters of the alphabet. Record the frequency of each character in its tree's root to indicate the tree's weight. More generally, the weight of a tree will be equal to the sum of the frequencies in the tree's leaves. Step 2. Repeat the following operation until a single tree is obtained. Find two trees with the smallest weight. Make them the left and right subtree of a new tree and record the sum of their weights in the root of the new tree as its weight. Encoding with Huffman trees. Huffman trees are an efficient way to encode data by assigning shorter codes to more frequently occurring characters and longer codes to less frequently occurring characters. This means that the most commonly used characters in a message will have the shortest codes, resulting in a smaller overall message size. The process of creating a Huffman tree involves building a binary tree where each leaf node represents a character and its frequency, and the path from the root to each leaf node represents the code for that character. For example, in a message that contains the characters A, B, C and D with frequencies of 5, 2, 1 and 1 respectively, the Huffman tree would assign the code 0 to A, 10 to B, 110 to C and 111 to D. This results in a total message size of only 13 bits as opposed to the 28 bits required if each character were assigned a fixed length code of 3 bits. By using Huffman trees to encode data, we can achieve significant compression without losing any information. Decoding with Huffman trees. Once data has been encoded using a Huffman tree, it can be decoded by traversing the tree from the root node to the leaf node, following the path indicated by each bit of the encoded data. When a leaf node is reached, the corresponding symbol can be output and the traversal can begin again from the root node for the next symbol. Now let us see an example. Let us consider the 5 character alphabets A, B, C, D and dash with the following occurrence probabilities. The character A has probability 0.35, B has 0.1, C has 0.2, D has 0.2 and dash has 0.15. In the step 1, we have to sort the characters in increasing order of frequencies. So in this example, B and dash are having the least frequency. So we have to add the first two elements and arrange the minimum valued frequency to the left node and maximum valued frequencies to the right node. In step 2, again we have to arrange the frequencies in increasing order. Now we can see that C and D are having the least frequencies, so we have to add C and D. So in step 3, again we have to arrange them in increasing order of frequency, and we can see that 0.25 and 0.35 is less than 0.4. So we have to add 0.25 and 0.35, which becomes 0.6. Now 0.6 is greater than 0.4. So 0.4 has to come to the left side of 0.6. Now this is the final tree. In this, for each non-leaf node, assign 0 to the left edge and assign 1 to the right edge. The resulting code words are as follows. Character A has code word 11, B has 100, C has 00, D has 01 and dash has 101. Here dat is encoded as 01101 and 10011 011 011 101 is decoded as bat-add. With the occurrence probabilities and the code word lengths, the expected number of bits per character in this code is given as 2.25. If fixed length encoding, we would have used 3 bits per each character. With Huffman's code, 25% less memory is used. Now let us see the applications of Huffman coding. Huffman coding is a data compression technique that can be used in a variety of applications. Here are just a few examples. The first one is the image compression. By compressing image data, Huffman coding can reduce the amount of storage space required for digital images. This can be especially beneficial for larger images or images with a lot of details. The second one is the audio compression. Similar to image compression, Huffman coding can also be used to compress audio data. This can save storage space and bandwidth when streaming or downloading audio files. Text compression. Text files can also be compressed using Huffman coding. This can be useful for reducing the size of text documents or email attachments. Data transmission. When data is transmitted over a network, it is often compressed using Huffman coding to reduce the amount of bandwidth required. This can help to speed up data transfer and reduce cost associated with transmitting data. Huffman trees in computer science. Huffman trees are not just useful for data compression, but they have a wide range of applications in computer science. One of the most significant applications is in network routing algorithms. Huffman trees can be used to efficiently route data packets across a network by assigning shorter codes to frequently accessed destination and longer codes to less frequently accessed ones. Another application of Huffman trees is in cryptography. Huffman trees can be used to create secure encryption keys by generating unique codes for each character in a message. This ensures that the message can only be decoded by someone who has access to the same Huffman tree. Thank you.